I am calling one of my famous audibles here. We are going to go forward with our OSPF router types. Definitely some important information here. But what I've done is rebuild our earlier lab that we put together piece by piece because I actually want to use this one to show you one little tricky definition of one of these router types, and just to use this to illustrate these four different router types that I'm going to start talking about and show you right now. With OSPF, internal router and backbone router, these are common terms. But ABR and ASBR, those are the two you really got to watch. And you got to be able to identify them, not just for your exam, but when you get into even more complex OSPF configurations down the road, you're going to need to be able to identify the ABR and the ASBR because you have a few commands, not very many, but a few that will only have effect on the ABR or only have effect on the ASBR, and you got to be able to identify them because the router might not help you along with that. So we want to be particularly careful about those two. But as far as an internal router goes, that's just an OSPF router with all interfaces in one area. Doesn't matter which area it is. Backbone routers have to have at least one interface in the backbone area. Nothing to that, pretty simple definition. Just make sure you have it down for your exam. Now the ABR, you really want to watch this one. It's a router with at least one interface in area 0 and at least one interface in another area. So that's where the area border router comes from. It's got to have a connection, physical or logical, to area 0. Now the ASBR, we saw that in quick action, limited action in the last video because we needed some extra routes. So I did a little route redistribution on it, and that made router 1 an ASBR as soon as I did redistribute connected subnets. It sounds kind of formal there, a router injecting routes. All you're doing with route redistribution is taking routes from one source and putting them in another. That's it. So instead of having another routing protocol running in that lab, I just took some connected routes, injected them in an OSPF via redistribution, made router 1 an ASBR. Whew. So with all that in mind, and all previous configurations have been taken off, this lab is exactly the way it was when we finished it up earlier. What internal routers do we have in this network? Quick answer there, right? None. There's not one single router here that has every interface in the same area. Every single router has a loopback in its own little separate area, and that means they are not internal routers. Now, what about that second term, backbone routers? One or more interfaces in the backbone area. You can pretty much do the old ocular scan and just look at that and answer it real quick on your exam, but you might be wrong. So let's talk about that, so we won't be wrong on exam day, about the ABRs. A router with at least one interface in area 0 and at least one interface in another area. Now we need to be able to spot those visually, of course, but there's an excellent command, show IP OSPF, that we've actually used for our other labs. And right near the top of the output, about 7 or 8 lines down, depends on which version of iOS you're running, it's going to tell you right there it is an area border router. And if it doesn't say anything, then it's not an area border router. So let's go around the horn here, and running on router 1, we see it is an area border router. No surprises there. And we'll run it on router 2. And no surprises there, about 8 lines down, it is an area border router. Router 3, 4 lines down, it is an area border router. Also gives you a little information about the backbone there. And router 4, it is an area border router. So we have 5 area border routers. How? How can that be the case? Because when we built this lab, we know that router 4 doesn't have a physical connection to area 0. It's one reason we had to build the virtual link, because area 4 did not contain an interface on a router that also had an interface in area 0. Yeah, I already hear you out there yelling it. The thing is, the virtual link is an interface in area 0. It's a logical one. And what a virtual link really is, it's an extension of area 0. So when you put a virtual link in like this, that router on the other end of the virtual link, the one that doesn't have a physical connection area 0, it is now an ABR because it has a logical connection to area 0. With the ABR, when it says a router with at least one interface in area 0, that can be a physical interface or it can be a logical one. And that's exactly what it was here. It was a virtual link. So how many backbone routers do we have? One or more interfaces in the backbone area? Technically, we've got 5 because router 4 does have an interface in the backbone area. It is just a virtual interface. It's that virtual link. So how about that ASBR? Let's talk about that for a moment because right now we're not doing any route redistribution. And I'm going to create some really quickly here on router 1. Let's just go up to 1 and we'll make a new loop back. Let me give you a quick heads up here too. With OSPF, with redistribute connected, it's a legal command, but you always want to use subnets. Just giving you a little preview before you ever get to route redistribution. Always put subnets here because otherwise you're not going to get your subnets. And having subnets is one reason we run OSPF, right? So we have now done a little route redistribution, a very little, but let's run show IP OSPF, and now you'll notice that we get the information. It is an area border and autonomous system boundary router. Now, a couple things about this term. First off, you can say autonomous system border router or autonomous system boundary router, and no one's going to get mad at you for using one term or the other. And the other thing is, you might be thinking autonomous system. You know, well, isn't that an EIGRP term? We do use autonomous systems in EIGRP all the time. We use them to logically group routers. And if you haven't seen that before, you're going to see it in the next section. But it is not an EIGRP exclusive term. Again, OSPF uses areas for these logical groupings, but the one place you are going to see the autonomous system term pop up is here with ASBR. But that's all there is to it. And again, you want to be able to spot especially ABRs and ASBRs for your exam, but you definitely will need to spot them as you continue your studies because certain commands, a very few, but a couple of very important commands you'll run into only run on ABRs and others only run effectively on ASBRs. So that is about it. Coming up next, a little bit of design info as far as limits on routers and areas, that kind of thing. And then we're going to get into some costs. We're going to take a look at how OSPF is coming up with these route costs because, well, let's just take a quick preview of that now. Show IP route OSPF. And, you know, a couple of values here in the brackets. And the first one is always going to be 110. That is the administrative distance for OSPF. And unless we change that somehow, it's always going to be 110. But these numbers in the second part of the bracket, that's the cost of the route. And that's determined by port speeds. And sometimes you have to do a little fine tuning to make that accurate. Then you throw a gig Ethernet interface in, and you definitely want to make some changes. And we'll see all of that coming up in the next couple of vids.